All right, so today we're going to focus more on the center of dilation and how to find where it was dilated about, or um, just more if the center of dilation is not the origin, or if they tell us it's somewhere else. Um, so if the center of dilation is inside your figure, then your shapes are usually stacked inside of each other in some shape or form. So you have these two examples, they're inside. So if your center of dilation is in the middle, then they are also inside of each other. If your center of dilation is on a side of your figure, then the side of your image and pre-image should be lined up. So instead of kind of floating in the middle, it's actually connected to a side. If it's outside of your figures might still overlap a little bit, but more often than not, they are separate from each other. All right, so drawing a dilation when the center is at the origin. So this is the easiest kind. When it's at the origin, then you just take whatever your scale factor is and multiply. So this O stands for origin, and then it's a scale factor of 2, which means we're taking our point and multiplying our point by 2. So if C is 1, 3, if I multiply both of those by 2, C prime is 2, 6. And then we can put that on our graph. So there's C prime. A dilation of 1/2 with center of dilation O, the origin. So again, since it's at the origin, we just take our point and we multiply by 1/2. So if A is at 6, -4, 1/2 of 6 is 3. 1/2 of -4 is -2. And for B, 1/2 of 2 is 1. 1/2 of -8 is -4. So then we'll put those on our graph. Okay. We want to make sure we connect those because if it was a line before, it still needs to be a line. If it was a triangle, whatever the case may be, it should still look similar. It's just changed in size. So this distance is 1/2 of this distance. A dilation of -1/3 with the center of dilation O, the origin. So the negative is going to change the direction of our line, so it will be facing a different way. So, but again, I'm going to take whatever my points are and multiply by -1/3. So that would make D prime -1, -3, and E prime -3, -1. So there's our D prime and our E prime. You should label these. Okay, so if you notice, these did switch spots. If without the negative, D should have been here and E would have been here, but because of the negative, they switched direction. Drawing a dilation when the center is not at the origin. So a dilation of 2 with the center at -3, 4. So right here's our center. And if dilation of 2 means we're going to double the distance. So here H is 1, 2, 1, 2, 3, 4, 5, up 2 over 5. So from here, I want it to double that. So that would be up 4 over 10. So this would be H prime, which is yeah, that's right, H prime, and that would be up 4 was 8 over 10 was 7. A dilation of 1/4 with a center at 8, 1. Okay, so 1/4 means we want it to take the distance and cut that by 4, or divide by 4. So if I go up 8 and over 12, so we're going up 8 over 12. Instead, if I take that by 4, I'm only going to go up 2 and over 3. So this is my G prime, which ends up at 3. So we went up 2 and over 3, so 5, 3. Dilate the triangle using a scale factor of 2. And it says our center is at C. So that means that since it's right on a point, that it'll be inside our current figure, but also kind of glued to one side, like we talked about in the very beginning. So C and C prime will actually be the exact same point. Here, B is up 1 over 2, so if I double that, that's up 2 over 4 for B prime. And for A, that one was up 3, left 1, so I need to go up 6 total and left 2 total. Okay, so if I've already done it once, I could repeat that process to get the next point because we're doubling it. All right, so that would be our image. Okay, this time we are using point O here in the center, and we are still using a scale factor of 2. So this one's up 1, I have to double that, so we're going up 2. Right 1, we're doubling that. Down 2, left 1, so I'm going to repeat that. Okay, that is a total of down 4, left 2. Okay, since it was in the center of our figure, our our pre-image and our image are still contained. All right, here we go. So using G and a scale factor of 2. So scale factors of 2 are common because they're easy to do, but they're also, you just repeat your process. So this is 2 to the right, I go 2 more for A prime. Here, 3 down, I have to go 3 more for a total of 6 for C prime. Here I'm going down 2 over 3, so that's where my B prime would live. Okay, so there's my new figure. And since my center of dilation was on the outside, my shapes do overlap, but they're not contained within each other. All right, this time we're doing a scale factor of -2, which means I have to switch the direction I go. So here's my G, scale factor is -2. So if I was going to go up 2, instead I have to go down 4. So there's A prime. Instead of going left 3, I have to go right 6 for B prime. And then this one would have been up 3, left 2. So I have to go down 6 and right 4. So there we go. Determining the center of dilation and the scale factor. So when you're doing the scale factor, I think it's easiest to just kind of look at your side lengths. Like here, this is very clearly 1 space, and this one's very clearly 2. So it is going to be double. And then since it's 2, I know that this distance has to match the distance from the center. So this would be 1, 2, 3, down 2, 1, 2, 3, down 2. And then you could check that, like this is right 2, down 1. If I repeat that, I do end up at the same spot. So you could check it for your other points as well. But it looks like our center is 0, 2. So it's like you're working backwards. This center has to be inside somewhere. This one was on the outside because our shapes are not contained. This one definitely has to be in the middle here somewhere. Again, if we look kind of at our lengths, this one is up 2 over 1. This one is up 1, 2, 3, 4 over 2. So it did double. So that means I could repeat this process. Up 1 over 2. I'd work backwards and end up right here at 0, 1. So now I'd be up 1 over 2, up 1 over 2, down 1, right 1, down 1, right 1, and so on. So you're working backwards for those. Last page for today, Dilation versus stretch. So stretch only changes one variable, but by different factors. So it could only be stretching it vertically or horizontally, whereas a dilation is doing the exact same thing to all dimensions. So a dilation would be consistent, so 5 times bigger, a third time, so a reduction, or this one would be 3 times bigger in a different direction. A stretch would be multiplying by different factors, so it almost kind of warps your shape. You're not keeping the aspect ratio when you are doing a stretch. So it says stretch, shape is distorted. Okay, this one is taller than it was before. Your multipliers are different, or it's distorted at all. It doesn't look similar anymore. All right, it looks like that's it for today. Your homework is pages 20 and 22 in the back of your book.